Welcome friends, thanks for watching my previous session. In this session, we are going to deal about distributed tracing in microservice world. You know, right, in microservices world, we have collection of microservices which are doing a group of tasks, like an activity. If you see my example, right, we have roughly 4 microservices and 3 predefined microservices. So there are several microservices, they are collectively doing one task, and you want to know how the task is achieved. Let me put it in simple term, like now if you want to get a report, employee report is served from the report API, right? The report API is calling employee API, payroll API, then it is calling the RabbitMQ. So the call is going across multiple microservices. You want to trace how that call flow is happening, then you need to have a methodology to identify how can you trace a request call flow. So this is what we are going to cover in this session. We are going to cover two important projects. One is Spring Cloud Sleuth. Sleuth is a tracing component, and which has an integration with Zipkin. Zipkin is like you can think like it's an UI, and it's also collects these trace IDs and stuff. Okay, without going, before I explain that, so remember that distributed tracing is like you want to trace the call flow from request to response. Like client made a HTTP request call for an API, and you have to understand which microservices the call traversed and how the response is served back. This is very essential for two prime reasons. One is like sometimes the customers complain that they are experiencing a slowness, then you want to understand which microservice is taking time, right? To identify which microservice is taking time, then you need to know what's the call flow and each and every layer, how much time the request has taken. So that's one purpose, to understand the call flow, to understand, to debug the performance issues. And third thing is like if you want to trace some errors, okay, like and some intermediately the microservices are failing, in which request flow the microservice is failing, that will help you to identify with the distributed tracing. So the name tracing means like you trace the call flow from request to response. Distributed means microservices. A distributed world, we have multiple microservices running. So and you will trace those tracing. Now let me take you to the whiteboard, and we have to understand few vocabularies here. How do you trace the call flow? Then we will, as usual, we'll try to understand the environment and stuff. Okay, let me take you to the next slide. First of all, what is trace? So a trace is like to identify how many microservices that request has traversed. Okay, from originating from browser, it hits the gateway, then it hits the APIs, like then it's the multiple microservices, and response is served back. So that's what you need to trace the call. Why do we need tracing? We know, right, to calculate the performance of each and every microservice, and at the same time to understand the call flow where that microservices are going, and to debug if some error is at some particular microservice. You need to do it. Distributed tracing means like the call goes across multiple microservices. It's in a distributed world, right? So that is what kind of distributed tracing. Terminology, this is very important thing you need to understand. Trace ID, trace tree. Like when a request comes and hits your first microservice and goes to 1, 2, 3, 4, 5, 6, n microservices and comes back by your first microservice and serves you back. That entire call flow from request to response, what customer gets, we call it a trace. So it's like the entire call flow is called trace. We call it a trace ID. You will have single ID which spans across all the layers, all the microservices. The next thing is like span. Like when a request hits a one microservice and the one microservice gives to the other microservice, right? So that is called span. Then 2 gives to the 3, 3 gives to the 4. So like 1 gives to 2, that is one span. 2 gives to 3, it's another span. 3 give it to the 4, it's got another span. So that's called span. I mean individual portions in that request flow. Span is like an individual portions in the request flow. So, or we call it a trace tree, like collection of spans. If you see, it's like a tree, right? Like the request comes, hit one microservice, then goes to another, then second microservice can give to 2 other microservices. So it goes in a tree fashion. So we call it a trace tree, span. Then a lot of people can confuse about, is it logs and tracing is same? Ideally not. So the main intention for tracing is to identify slowness and potential errors, but not to understand the system behavior. Okay, partially to understand system behavior as well, but we will have a separate logging mechanism. Trace is mainly meant for to see how the request call flow has been. So that's what. Now, what are the technologies here we used? So there is a project called Sleuth. Spring Cloud has a project called Sleuth, where when a request comes to it, it identifies the trace ID, span ID, what is a parent request, everything. You need to have those logics, right? So those logics that Spring Sleuth takes care. So when a request comes, if it's a new request, it will assign a trace ID. No, if it is already having a parent, it came from some parent, it will assign a span ID or parent ID to it. So that's what the Sleuth project does. Sleuth calculates the trace and span and give it to Zipkin. There is a Zipkin client program. Okay, the Zipkin client program takes that and put it in a RabbitMQ server. So essentially what we need is like this trace information, we are not putting it in any database, or we are not putting it in any file system. The trace information is placed in message queue. So each and every microservice in our flow will write to the message queue. The trace information is written to microservice. Each and every microservice writes trace information to the message queue, and we have a Zipkin UI component which reads from message queue and puts it in its in memory and show it in the UI. Okay. Anyhow, when I show you the whiteboard, I'll explain you that whole thing. So this, as I said, right, this entire tutorial is documented in my GitHub repository. You can get it there. So the first thing what you have to understand is this is my request flow. When someone asks to get a report API, which is nothing but employee name, employee salary, that's all. Very simple thing. If you watch my previous videos, you will understand this. This is the same enhancement to the first example which I have taken. So the request comes to gateway, hits the report API, then the report API make a synchronous call, means it waits till employee and payroll API response, and it sends a message to RabbitMQ, like it puts some message, the employee details, and mail client sends email to him. This is like you already know. I need not to explain this. The main crux here you need to understand is like every microservice writes the trace information to RabbitMQ. So that is what you need to understand. So let me take the whiteboard. This is what I'll come back to trace and span IDs first, but I'll explain you the few key points which you need to remember. So let me open the whiteboard. So I have, sorry, let me choose a different color. So I have gateway, one microservice. We have registry, one microservice. Leave about thing. All finally we need to have is like RabbitMQ. Okay. Then we have two other microservices, employee, payroll. Okay. And we have mail client, and we have report API. These are all microservices, you already know. So every microservice writes information, the trace information to this. Like the call flow is like browser asks gateway, then gateway writes trace information to RabbitMQ. From gateway, it comes to the report API. Then report API writes trace information to RabbitMQ. Then report API asks employee to get the employee details. Employee writes here to RabbitMQ. Trace information, don't remember the request. Okay. Similarly, report API asks payroll API. Payroll API writes the trace information to RabbitMQ. So similarly, it publishes, you know, right? Our report API publishes to RabbitMQ to demo or asynchronous communication. Okay. So that information also it writes to RabbitMQ. So RabbitMQ has the entire information. Now, the next important component what we need to have is Zipkin UI. So Zipkin UI reads the trace information and provides you a nice user interface. Okay, Zipkin server runs, it reads the RabbitMQ for that whole call flows and show you to in the UI. Currently, we use Zipkin. Few people uses several patterns. Okay, people uses Zipkin has a data store. Okay, right. Currently, we use memory as a data store. Like it stores in memory whatever the data it from RabbitMQ, right? It is putting it in memory and showing it in the UI. Instead of that, people can use MySQL or Elasticsearch. Okay, you can use various data store to store your trace information. So currently, that's beyond the scope of this tutorial. How do you configure Zipkin to use Elasticsearch as a data store or NoSQL DBs as a data store? We primarily focus on Zipkin takes the trace information from RabbitMQ, puts it's in memory, and use a visualization to show it. So that is what we are focusing on. Okay. So now two terms which you need to understand. One is like trace and span. Let me create a new board. So this is what you need to understand. So for example, if a request coming from microservice 1, go to microservice 2, microservice 3, and microservice 4. From microservice 3, it goes to microservice 3.1.1, for example. Leave about that, okay? Or it can to represent your tree. So this entire call flow, we call it as a trace. Okay. So this is called span, SP1. This is span 2, span 3, then span 3.1.1, because they are happening parallelly, right? That's the reason I wrote span 3.1.1, something like that. Okay. So even there is no span ID, people you confuse the term with span, but you can just say that there is one trace ID across all the call. You need to switch, right? There is a one common trace ID which is common across the call, and then individual spans will have their own trace IDs. It's okay to call them as a span ID also. A typical will be like where you will have trace ID, span ID, and parent span ID. You can call it a parent span ID or parent. This is a like typical representation. If you have, you can compute everything. What is a parent to it? Okay. This is how this is the difference between trace and span. Trace tree is nothing but this is called trace tree, like M2, M3, M4, M2, M3, M11. This is called trace tree. So now you understood the difference between span and trace. Let us quickly jump on to demonstration. So as you know, right, I always run I'm running RabbitMQ and Zipkin inside a Docker. My base OS is Windows. I'm running a CentOS virtual machine using Vagrant. I'm using Vagrant and VirtualBox. Few of you asked me, okay, how you are running your virtual machine? I'm running it in a VirtualBox. Okay, VirtualBox is from Oracle, and you can run your virtual machines. I use vagrant to orchestrate to sprint the virtual box, which is running CentOS 7. After that, I run the RabbitMQ and Zipkin inside a Docker. That's what, if you see the screen, that is what it shows. So Zipkin and RabbitMQ is running. So RabbitMQ lives on 5672. This is an MQ port. This is like messaging port. It is also having an UI 15672. It is UI. I port forwarded that to the physical host. Then Zipkin runs on 9411 UI. So that's what a Zipkin UI is. Now you can do a Git clone of my repository. Sorry, where it is, yeah. You can do a Git clone of my repository. Here it is there. So distributed tracing, you can do a clone. Currently I cloned the repository to this location. Now the first thing is like we have to bring RabbitMQ and Zipkin servers, right? This is the first tab is like RabbitMQ and Zipkin. Vagrant up. If you do vagrant up, it will bring the virtual machine, install all the necessary softwares and stuff. Because it's a quite time-taking process. It takes minimum 5 to 10 minutes to bootstrap the machine. I'm not doing that. Now let me go into the machine and start RabbitMQ. Vagrant SSH. Then let me switch to root. Sudo su minus. Then cd vagrant. Pay attention to this folder. Few people ask where your code is there. So it will be in the /vagrant folder. Okay, if you see, the /vagrant folder will have all the Git code what you clone. Essentially, it's from your Windows machine. It is mounting there. Okay, so there is a Docker compose file. If you want to see vi docker compose .yml. So these are the two services which is going to run. One is like Zipkin and another one is like RabbitMQ. If you see here that the Zipkin server should start when the RabbitMQ is healthy. So it's what Rabbit depends upon. The Zipkin depends upon RabbitMQ. Okay, so that's the reason I said that dependency in my Docker compose. You really need not to focus that when I'm covering the Docker compose and stuff. I'll explain you when you're deploying microservices. So the first thing what you need to do is docker -compose up -d. So this is the command which you need to run to bring the environment up, to start RabbitMQ and the Zipkin server. I already run it, so I'm not running this command. If you want to see what is the status of it, docker compose ps, it shows that the Zipkin is running on 49411, which is technical expose in the port 9411, and RabbitMQ is like 5672 and 5672. These are the things what I showed you in the page. Okay, 15672 and 5672 and 9411. So now our entire environment is up. If you want to make sure that everything is up or not, log into RabbitMQ. You can see here there is a one connection, which is the Zipkin connected to RabbitMQ, and you just see whether you are able to access Zipkin or not. Okay, so this is where 9441 access Zipkin, and you can use the RabbitMQ UI. So now we have the environment. It's good. So now let us bring our standard services, like all the microservices comes up, they register with the RabbitMQ and sends the trace and span information to it. Okay, every microservice connects to RabbitMQ and publishes the trace information. That's what you need to remember. It can be gateway, it can be a registry, it can be employee, payroll, report, mail. All the microservices sends trace information to RabbitMQ, and Zipkin UI, we are reading it from that queue and display it in the UI. That is what we are going to do. So now let me build the code. The first step what we do is, let me check if there is any processes. No. Okay. mv clean install. So it's a very standard thing. You because my artifactory doesn't have my repository doesn't have artifacts. You clone and you build it. Now the first step is like I'm running the registry microservice java-jar registry, okay, .jar. When this registry microservice is coming up, it will connect with the RabbitMQ and try to publish any request it is getting to it. So that's what every microservice do. So you can see that service registry started on 8761 and it is also connected to the RabbitMQ. If you see the log, you can understand that it connected to the RabbitMQ. Okay, similarly, we will start the employee microservice. Then we will start the payroll microservice. Now I'm starting the payroll microservice. Then I'll start the report microservice. If you see, right, now we started 2 microservices. Every time when a microservice comes up, it connects with the RabbitMQ. If you're seeing here now, we have this connection is from Zipkin, UI server. These 3 are from employee, payroll, registry. Now let me bring the report API. It also connects with MQ server. So it's coming up. Now you have. So once it connected with the RabbitMQ, you can see that there is one more connection made to RabbitMQ. See here, there is a 5th connection made to RabbitMQ. Okay, so then run the mail client. It also connects to RabbitMQ. Okay, and finally we will run the gateway. This also connects to the RabbitMQ. Okay, so now our entire environment is up. Before the whole environment, it takes time for the whole environment to get settled. Probably we'll give it for some time. So in the meanwhile, then we'll go a little bit into the code, which is very simple, very simple. To enable distributed testing to your Spring Boot microservice, it's very easy. We are going to dwell a little bit into the code, then we'll come back with the trace demo. So let me take you one simple microservice. This is a copy paste of across all the microservices. So if you see the POM, in the POM you need to have these 3 dependencies. Okay, you are using Sleuth. Sleuth, you know, right? Sleuth will compute trace ID and span ID, and which gives to Zipkin client. Zipkin client puts it in the RabbitMQ. Here I am using RabbitMQ as a message bus. You can use Kafka as well. So Zipkin works with Kafka also. But essentially you need to write it to the RabbitMQ message bus. Okay, don't use any HTTP post or something like that, okay, for the log messages. So this is the dependency you need to have in all your microservices. That's all you need to know. If you add this dependency and you say where is the configurations of your RabbitMQ, that is in our application.yaml. Here we are saying that, okay, Rabbit, it is say you use the RabbitMQ. By default, I'm using the default details of RabbitMQ, right? This is like the RabbitMQ, Zipkin is sending it to Rabbit. This one thing, Sleuth sampler probability, Sleuth sends only by default 10% of the request, not each and every request. So, but for the demo sake, I added every request the Sleuth has to send trace information to the RabbitMQ. So based upon your deployments, okay, you can decide what is the percentage of trace information should go to the RabbitMQ. If you feel that you need to send entire trace information, that is also fine. So that is what the probability says. One means it sends every trace ID information to RabbitMQ. So this one property you need to focus, and these are the two properties. Every microservice has the same. Okay, so let us demo the call and see what's happening. Let us call report microservice to give report. You know, right? Report microservice is nothing, very trivial microservice, where report microservice call employee, payroll, and message bus. It calls 3. So let me do a curl. Let me do a curl. Here what I'm saying is localhost report API and 100. Sorry, I think you are getting a report of an employee with 100. If you just press enter, and the report came. So the name came from employee API, salary came from payroll API. Okay, name is Alex and his salary is $65 US, $65,000 US, 65K. So let us see. Now you know, you coded it, you know pretty it very well, but this information is very nicely present in Zipkin. Okay, so let me go to Zipkin UI. So the Zipkin UI, let me filter. So service name. What are the services? We have several services. We are more interested in gateway, right? The call came from gateway, and we say run query. So this is the call that came. This is the call that asked the employee report. This is the call, HTTP call. Okay. So let us understand how much time it has taken. The entire call took 2.56 seconds. This is what the call duration, the 2.169 seconds the entire call took. Okay, so here you see the gateway is hitting report, and the report API is calling employee API and payroll API. So how much time that employee API has taken? It has taken 309 milliseconds. The payroll API has taken 310 milliseconds, and report and mail client has taken 362 milliseconds. Okay, so it nicely show you this end to end is like your trace. This is what a single trace ID, and everything is a span. So from report it is spanning, from gateway it is spanning, and mail client is also it is spanning. So these are the spans. You know each and every layer how much time it has taken. So let me show you a little bit few interesting things. So employee API, let me click on employee API. What is the call that got triggered on employee? See, the employee API, this is the employee controller, and get employee details is a method that is called. So it's such a nicely presented, right? You really need not to go and know the code. It will clearly show get employee and 100. So if you see the report API, right? The same thing, which is calling report API, and which is passing employee ID, so which is invoked by report controller and get method. And you should be asking me question, why gateway came in middle? Why report API is not directly calling employee API? I already said, even inter microservices communication should happen via gateways. That's the right pattern. That's the reason. So now payroll API, now similarly report API is calling payroll API via gateway, and that's the reason gateway is coming in middle. Even the same thing, if you go to the payroll API, payroll control and stuff. Now it is calling employee, it is calling payroll, and it is sending data to the message bus as well, right? You already know if you see my report API. So if you see here, out, it is writing to a channel. So your microservice is writing to a message bus. Don't confuse with this trace information. This is my program. Okay, asynchronous communication. When I'm showing, I showed how a microservice write to a message bus, another microservice reads from a message bus. So the report API is writing to the message bus. This is an output channel, and broker it is writing. The broker can be RabbitMQ, Kafka, anything. Similarly, the mail client, if you see, the mail client is reading from input channel, RabbitMQ. So this is like very nicely presented with all your call flow, how much each layer is taking. Let us send one more call, how much time it has taken. So I send one more call, go back, search service name, gateway, run query. Okay, so I'm not interested in duration, but I'm interested in start time. So the new one took 50.68 microseconds, very little time, and it shows you the entire call flow. You see the whole call took 50.699 microseconds, and how see the asynchronous sends are very small time they're taking. Okay, so report API is calling with employee ID, which is calling employee API, payroll API, and it is doing a send to the microservice. So Zipkin is a very Zipkin and Sleuth are very good projects. You get these all things for free. And if you want to implement this trace and span on your own, it's not a complex, it's not an easy thing to solve. So I think pretty much I covered everything about Sleuth, Zipkin, why tracing is important. So I'll show you now. I'll distribute an error, like let me stop the payroll API. Okay, so now let me do one thing. Let me send a call. Curl. Okay, so I got 500 error. Report I didn't get because my some API, some microservice got failed. Now let me see from my gateway what has happened. Run query. If you see here, right, it clearly shows start time. That latest call is failed, and the employee API, it was successful, but after that it failed at the report. So it called the payroll API, which it is unable to get. So you see the connection refused. Which one? The payroll call failed. So this is a good tool for us to understand if a particular microservice is not executing properly. Okay, hope you liked the distributed tracing. If you have any questions, please drop a note. Thank you very much.